Hi and welcome to Concept Based. I'm John Hepworth, and this one today again goes out to the Year 11 Advanced students who've just started off their year, who are most likely working in the topic of algebraic techniques. And what I want to talk about is the forms of factorisation that are available to you and what students will often do, and what you yourself might actually do, and some ways to possibly make your algebraic techniques a little bit more efficient, a little bit more effective, and definitely a little bit more flexible, because you're looking beyond just the first thing that you see, to try and create some ease for yourself, certainly in expressions that become more and more complex. Now, first of all, I'd just like to note that this does go back into your Year 10 content from Algebraic Techniques C in that path content. You were doing some special factors in there. So if you are feeling like you need to brush up on some of your algebraic techniques, you should be able to go back into some of your Year 10 content and have a look at all of the forms that you were using. But this year, it's coming out of obviously your Stage 6 syllabus in working with functions in algebraic techniques. And so we're going to look at the factorising here of this expression. Now, essentially there is two paths that students will take out of this expression, and neither of them are wrong. And often when you talk to a student that chooses either of the paths, they will want to stick with the path that they naturally use because that's the way that they do it. I don't know if you may have heard comments where students will say, I know how to do it, it's just my teacher doesn't like it the way that I do it. I understand that, and having a particular way that you like doing things is certainly very good, and it gives you that sense of comfort and ease and familiarity where you've done it regularly. But sometimes, we have to get to the point where we evolve our processes to something that's the most efficient. Because when we go into the HSC examination or maybe a school-based assessment task, there are time restrictions. And so with there being time restrictions, not only do we have to be accurate, we have to be fast. And so there are often ways to increase the speed of what you're doing, and sometimes that means just completely changing the method in which you are doing something, and taking on a new method that your teacher is most likely recommending to you, even though it's completely foreign and new. Hopefully in this little video I'll try and show you why one technique is not foreign and new in comparison to another one, and a method that I use for my students to try and make them feel more comfortable when taking this on. So I suppose what I really want to the students I really want to talk to about this factorisations are students who want to expand, gather like terms, and then factorise. In this situation, that is challenging because it does create a cubic, but in the future you will be able to factorise cubics. But if it's something where possibly, they take out an x term at the front here and then work with a quadratic in their expansion, it works, and it is a way that you can go ahead and solve this. But what I want to do is say, hey, there's potentially another way that you can be doing this, and that is as follows. When you're doing factorisations, you should be trying to have your factorisation go back to some sort of core tool that you used in your factorisation. So for example, you've learned difference of two squares, factorisation by pairs, all of the quadratic factorisations. Some of you may have actually explored some extra paths and done sums of two cubes and difference of two cubes and gone beyond. However, the one that I'm really looking at here today is really just pulling out a single factor out of this expression as much as you can before you go ahead and move into the second phase of this one. So looking at this factorisation, the first thing that I want to see whether you understand or not is that this x minus 1 in brackets and this x minus 1 in brackets squared, we can actually think of that x minus 1 as its own individual term. Now, if I was to completely rewrite this and rewrite this as b times a minus c times a squared, I think that you 100% would know what factorisation to do. You'd be like, oh yeah, there's an a that is common in those two, and I'm going to get a outside of b minus ca, and I have factorized an a out of there, which is great. And I often will see advanced students have no problem with identifying that that a is what they need to pull out. However, when the factorization is a question that looks like this, there's just this inclination to want to expand, that the path forward is expanding and simplifying and then factorizing, and that's just not the case. You have to be looking in and going, is there anything in any of the terms that are the same so that I can just factorize those straight out? And as I pointed out there is. The x minus 1 is in both, and in fact in this, there's an x in this one and in this one also. So we just want to take those out like the same way that we took the a out when we were doing the ba minus ca squared. So we're going to take an x out, we're going to take an x minus 1 out, and we're going to see what we're left with. Now when I do this, I always change brackets in this situation to square brackets. Why? It just teaches me or reminds me that the curly brackets here, the first one that I've done, is something that I've taken out the front, and the square brackets are indicating things that I have left behind, just so as I make sure that I make those steps correctly and I don't confuse any of the factors while I'm writing it out. So I then go and say, well, what's going to be left out of that first expression are 2, and what's going to be left out of this second expression, there's going to be a negative 3, don't go wrong with your negatives, and an x minus 1. Now you notice I'm writing the curly brackets there on the inside of my square brackets, so there's some clear definition between which parts of this factorization I'm writing. Now, once I've done factorization first, those students that want to go ahead and do that expansion first, now you have the opportunity to do the expansion inside the factorization. Because look at what I'm left with. This expansion that I'm going to do inside the factorization is significantly simpler for one reason, and that's this. There's no squared term there now. It's just a linear expansion. So it's far less complex, and the chance of making a numerical error when you're doing a linear expansion inside your factorizations is significantly less. So factorizing here first makes it much simpler for when we go and do the expansion, which we are now going to do. So x minus 1. Now look, I could dump the square brackets at this point and then just go ahead with curly brackets again, because that's what's going to be in my final answer. I only just used them to really clearly define what I was doing in that step. 2 minus 3x minus 3? No, plus 3. Such a common error, the double negative at the end there when students are expanding inside brackets like that. And now we can just tidy up that second bracket, and we have our factorization. 2 plus 3 is 5 minus 3x, and it's factorized. Now look at these factors. 5 minus 3x, that's not a nice factor. You know, like if we're looking at, what would we be looking at here? 5/3. The 1 is a good factor. The 0 is a great factor. So if we were going to try and do this by expanding first up the top and creating a cubic, we could have taken an x out, and then we would have been factorizing a quadratic that had not the greatest factored pairs behind it. We would have had to do grouping by pairs in that quadratic. So going down that path and going that way, you are able to get it correct. I mean, I'd even love to just run through it here and show you the expansion, gather like terms, take an x out, do the quadratic, solve it that way, and get it. And that's great. That's all correct algebra. But look at what I've done here. Just 3 lines of working, and I have completely factorized this cubic out, no problems. So I would highly recommend, if you're the student that is expanding everything first and then getting it down to your factorizations that you're really skillful at, that's great that you have those skills, but don't adhere to it. Don't stick to it and be like, this is the way I do it and this is the way I like to do it. You need to be flexible. You need to have a range of tools in your belt for a range of different situations. Try and look for these factorizations that you can do first before doing any sort of expansion, so that you can try and minimize the amount of working again, so that when you're in the HSC or in your trial or in your school-based assessment task, the speed with which you're working is much faster. I would even say that there's less procedural steps, which means there's less chance of making one of those negative errors or something like that. So here we have a factorization by finding a common factor straight up, first of all, and then tidying up that second factor. Is this concept-based? I think it is, because the reason why I would think that this is concept-based and not procedural-based is this. If you are thinking, I always expand and then factorize, that is a procedure. If you are thinking, I'm looking for basics where I can do things that I know have certain situations, you might know this one, SOAP. Does anyone know the SOAP acronym for this one? You might, so when you know all of the different types of factorizations, obviously there's a bunch more, there's no quadratics I've put in there, then you're drawing on a pool of understanding that you can use any of these tools at any time. We don't want to just have one fixed path of expand and then factorize. We want to look at it and go, can I factorize first? In this one we could, and we did. Again, if this is the sort of understanding that you're looking to bring into your mathematics and you would like some more information and possibly to work with me at Concept-Based Tutoring, then feel free to flick out an email to me, info@conceptbased.com.au. I'm John. Have fun.